All right, class. So, I finished my last lecture talking about calcitonin. Let's talk a little bit more about calcitonin. So, as I mentioned before, calcitonin is secreted by the parafollicular cells of the thyroid gland, and the calcitonin is released in response to high blood calcium levels. So when blood calcium levels are high, the calcitonin tells specific bone cells called osteoclasts to promote dissolution of calcium phosphate crystals. Sorry, my bad. Just ignore that. Silly me. Okay, so when the blood calcium level is high, calcitonin inhibits osteoclast activity, therefore inhibiting bone dissolution. So calcitonin causes the bones to retain calcium. Calcitonin causes the bones to retain calcium, and it also causes the kidneys to release more calcium via urine. And by these two mechanisms, the blood calcium levels drops, coming to normal. Therefore, homeostasis is maintained. So one more time, calcitonin is released by the parafollicular cells in response to high blood calcium level. Calcitonin causes the bones to retain more calcium, and it also causes the kidneys to release calcium via urine. Both these mechanisms lowers blood calcium level, which then functions or which then helps to bring things back to homeostasis. All right. Now, what happens if we do not get iodine through diet? Well, if we don't get iodine, remember the process of thyroid hormone production? So if you don't have iodide, obviously you cannot make T3 and T4, which are thyroid hormones. So no iodide, no thyroid hormones, right? And that leads to a disease state called goiter. In the picture in the right, we do see a person with a highly enlarged thyroid gland, a condition called goiter. So what's happening here? Let's talk about this. So let's say we have no iodine. So we have inadequate iodine, less iodine. So if we have less iodine, obviously we will have low T3 and T4. And therefore, if you have low T3 and T4, these hormones cannot go back and repopulate the receptors on the anterior pituitary and hypothalamus, right? So you don't have this negative feedback loop. This is not working then. And therefore, since you have low negative feedback or no negative feedback, that tells the anterior pituitary to release more TSH. So the anterior pituitary is confused. The anterior pituitary will think, oh my God, there is no T3 and T4. So what do I need to do? I need to produce more TSH. So it'll keep producing TSH in excess. So we have an excess TSH that will overstimulate the thyroid gland, and overstimulation of the thyroid gland will result in hypertrophy, and you will have a very enlarged thyroid gland. So to review, if everything is going fine, if you have enough, so let's erase this. Okay, so let's say you have enough iodine. So you have enough iodine, you produce T3 and T4, and when you have enough thyroid hormones T3 and T4 in your blood, that sends a negative feedback to the anterior pituitary and the hypothalamus and tells them everything is fine, no need to make more TRH or TSH. So we do see a good negative feedback inhibition loop here. However, if you have less iodide, then you have less thyroid hormone, so you have low T3 and T4. The T3 and T4 is so low that it cannot populate the receptors on the anterior pituitary and hypothalamus. So there is low negative feedback or no negative feedback, which causes the anterior pituitary to secrete even more TSH, which overstimulates the thyroid gland, and we have a hypertrophied thyroid gland. So your thyroid gland is super enlarged in this case. Okay, let's talk about some diseases associated with thyroid gland. So iodine deficiency leads to overstimulation of the thyroid gland, as we saw in the last slide, and that leads to a disease state called goiter. It can also lead to hypothyroidism, meaning a patient will have low metabolic rate, weight gain, lethargy, poor adaptation to cold stress, and myxedemia. And also in such patients, in case of severe hypothyroidism in adults, we can have myxedema, in which mucoproteins and fluid accumulate in the subcutaneous connective tissue, producing edema that causes swelling of hand, face, feet, etc. Okay. Then there is another condition called cretinism that results from hypothyroidism during pregnancy to about 6 months after birth. And let's talk about cretinism a little bit. Because of its stimulation of protein synthesis, children need thyroxine for body growth, and most importantly, for the proper development of the central nervous system. The need for thyroxine is particularly great when brain is undergoing its greatest rate of development, from the end of the first trimester of prenatal life to 6 months after birth. Hypothyroidism during this time may result in cretinism, and people with cretinism suffer severe intellectual disability. Okay. Now, a disease that is associated with hyperthyroidism is called Graves' disease. It's an autoimmune disorder in which some autoantibodies bind to the receptors of TSH on thyroid gland follicular cells. So the idea is there are some antibodies that bind to TSH receptors on the thyroid gland. This causes growth of thyroid and stimulates excessive secretion of thyroid hormones. Although TSH levels are very low because of negative feedback, the thyroid continues to be stimulated by thyrotropin receptor antibodies to grow and secrete thyroxine. Unlike people with endemic goiter caused by iodine deficiency who are hypothyroid, those with a goiter caused by Graves' disease are hyperthyroid. The hyperthyroidism produces such symptoms as sensitivity to heat, palpitation, and others. Many people with Graves' disease also have Graves' ophthalmopathy, where anatomical changes in the orbit of the eyes produce bulging of the eyes, Graves' disease is the most common cause of hyperthyroidism and is 5 to 10 times more common in women than in men. So for testing purpose, just know that hyperthyroidism can lead to a disease state called Graves' disease. That's it. That's all you have to remember. This chart is showing comparison between hypothyroidism and hyperthyroidism for testing purpose. I don't expect my students to memorize this. This is just a good slide. I thought the chart is informative and you can see the different features associated with hypo and hyperthyroidism. That's it. You will not be asked a single question on your exam based on this slide. Looking at parathyroid hormones, let's talk about the anatomy first. The parathyroid glands are 4 tiny glands embedded in the back of the thyroid gland. So these are the 4 parathyroid glands in red. Do you see these? These are the parathyroid glands. There can be 4, there can be more than 4. All right, now how do the parathyroid glands work? Parathyroid glands are stimulated when the blood calcium level is low. So low blood calcium level stimulates parathyroid gland to release PTH or parathyroid hormones. The parathyroid hormones work on the bones and tells the bone to release more calcium into blood. It also causes the kidneys to retain more calcium in the blood and thereby bringing up blood calcium levels. So this is another diagram. So when we have decreased blood calcium level, we have low blood calcium level. That stimulates the parathyroids to produce parathyroid hormone or PTH. The parathyroid hormone works on the bones and tells the bone to dissolve some calcium salt. So calcium can be released into the blood. It also works on the kidneys and tells the kidneys to uptake or reabsorb more calcium, which will then eventually increase blood calcium level. And when blood calcium level comes back to normal, we have a negative feedback inhibition loop, bringing things back to homeostasis. Okay, I'll stop here and start a new video with adrenal glands.